And ladies and gentlemen, welcome back to my channel, guys. Welcome back to my channel. In today's video, I'm gonna talk more about deformation on building, on this building, this reinforced concrete building that you have been designed since it's a couple of days now. All right. So I'm gonna talk about the deformation and how we can reinforce this deformation to maintain the stability of the house for lifetime. Okay, so it's more interesting. So just make sure to join the community by sharing this video, by liking this video, and also the most important, guys, I beg you guys, subscribe to my channel, guys. Subscribe. I beg you guys. Without your support, my channel is nothing. Okay, so I need you guys. Share the video, like the video, and also subscribe, guys. You guys are so amazing. All right, so what I'm gonna do here, I'm gonna perform. So first of all, before I perform the analysis, I'm gonna give summary of what we did before. So in the previous video, you can just go and check those two parts. The first and the second part, we design house with beam and columns and the wall, and we apply different type of loads. We apply dead loads, we apply live loads, dead load. We apply X direction in Y and X direction. We apply wind load in X and Y direction. It's so important. And also we apply the seismic load for eccentricity in X and Y eccentricity, but X in positive and Y, and I mean X in positive and also in negative, and also in Y eccentricity in positive and negative direction. And also we applied the safe weights of this building. Okay, so now before I perform, if I click here on perform analysis, I don't want to click right now, but if I click before I click here, right, I need to make sure that I define the boundary on this building. Otherwise, even if I click here, nothing gonna change, right? I can perform any analysis if that's defining the boundary of this building. So I'm gonna change the view to in front view. I'm gonna show on the right view. I'm gonna have this kind of illustration, okay? And here I'll go on boundary, and under boundary I'm gonna click on define support, and here I'll select the border, the border node here. So I will go on selection. Select by window. I'll select all of these nodes, okay? And because it's fixed, right? So this support means the foundation. So the foundation means is the part of the structure which supports the upper body of the structure, right? This is like a foundation, right? We know the foundation. Everybody knows the foundation, right? And then here, D and R, all of them should be click. So it should be fixed in X and Y direction. Okay, and then I'm gonna just click apply. Now you can see we have defined our supports. I'm gonna close it, and then if you go on top on the menu, on the work menu here, we must see that we defined our support has been defined to 1-1. This just like a call they give to you 1-1. Don't worry about the 1-1. So this means that we have defined your support successfully. Okay. So all right. So now we have our support. So next, I need to know the deformation on this building. In next video, after this video, I'm gonna show you how you can reinforce this building to overcome all of the deformation and to stay stable. All right. So here I'm gonna click on perform analysis. And I'm gonna wait a bit because we have a lot of nodes, right? My weights, and now we can see the computer has logged. The software has logged this design. Means that I can make any other change since I perform the analysis. I can make any other change. I can modify any node. I can modify any parts. I can change the material. I can change the section. If I want to change the section, I can just unlock the design and then perform the analysis again, right? So now you understand. So now, since we have a lot of, so the first step, we can go to analysis first here, to results. For the results, so the first thing that you have to do before you do anything, you have to combine all of the load that you define. We defined the live loads, or we defined live loads, dead loads, seismic load, and what again, and wind loads, right? So all of those loads should be combined. Like combined means combination of something. Like live load, dead load, and wind load X direction, right? Dead load, live load, and also wind load in what direction? Do you understand, right? So you have to combine all of those loads in order for us to perform the analysis on this building perfectly. So I'm gonna go again on the results, and then under results, I'm gonna go on load combination. I have a video about load combination. You can just go and check it and understand the load combination. And I'm using concrete design. I'm gonna click on concrete design here. I've performed it before, so all right, it's just the same. I can delete it. I can do it again. So just click on design on concrete design, okay, and then we can auto generate it. Okay, we can click on auto generation. And then under the auto generation, right, on this automatic generation load combination, we can, on the design code that I'm using, for the design code I'm gonna use, I will use the same. I'm gonna use hero code 2. I can just take the one 204, and the national annex I will take the recommended. Okay. And then here, all of the other parameters are gonna stay the same. And for the partial factor, for action, it should be 1.35 or 1.5. This can change according to your country. Some countries use different codes, right? So this gamma G can change according to your country. Okay, so I'm gonna click on enter. And now it has been performed. This is how it can look like. So let me just give you a summary of why load combination. So let me just enlarge this part. All right, so the first load combination that we have, let's say how many combination we have for this building. The load combination that we have here is a lot, because you can see we have 1 2 3 4 5 6 7 8 9. We have 9, so 9 times 12, right? So it's a lot. So no, it's not 12. So we have a lot of, you can just count. So you have a lot of load combination, right? So I'm gonna explain first. So I'm gonna just take one randomly and then explain. So the first one, let's start with the first one. So the first load combination that we did, we just combined the dead load and live loads. Live loads, I took 100% of live load. So we have 1.35. This is the coefficient for the dead loads using error codes, right? You have to take 1.35 plus 1.5 for the live load. But live load, I need to consider the 100% of the live load. So that's why I put 1.0. Okay, and this is the first combination. The second combination that I did, of course I combined dead load and live load the way that I did in the previous load combination. Then now I need to add X direction. I need to combine wind load in X direction. For the wind in X direction, I need to take 1.5. Okay, so I explained all of this load combination in the previous video, so you can just go and check, or I can make another video if you want about load combination, because it's a little bit complex idea. You have to understand how to combine all of these load, right? So this is how the combination works, right? So you can just go and check it out, my video that I made, or I can make another one if you want. Just leave a comment what you want. I'm gonna do it for you. And it's all of the combination that we did. Okay, so now I can just close this table. I don't want this anymore, and I will change the view to the normal view. Okay, and here I will go and analysis. So our point for this video is to see the deformation, how the building can deform, how can the moments and the shear can deform this house. So for the structure, you have to know, right? We have moments and we have the shear wall. If you cut the beam into like, if you cut the beam, right? So you know the beam. If you cut the beam into two parts, like if you just if you make a section the beam, you have the moments, the rotation of the beam, and also you have the shear. Shear is the internal forces, right? I can make a video to explain everything, right? But before I explain that, let's just explain our structure first, and I can explain the shear in the moment later. If you get confused, just leave a comment. Any question. If you get lost, just comments below, and then I'm gonna explain back to you. Okay, so here this is our parts, and we're gonna go on diagrams on deformation. I'm gonna click on deformation and deform shape. Okay, I'm gonna wait a bit. All right, and I don't want to take deformation. I'm gonna go on forces. Okay, let me just go on deformation first. Let me start with deformation first. Okay, so this is our initial building, right? Nothing had been deformed yet, right? But we have to know how the building can deform, right? If we don't reinforce it, right? So here, uh, the deformation shape, I will change it. Okay, I can leave it the way it is. Let me just go on force first. I'm gonna go on force first to understand clearly. I'm gonna go on forces, and I'll change the truss forces into beam because I'm using beam, right? I will use beam diagram, okay? And the load case is combination. I'll restart with dead load. Click on the dead load. Dead load is DL is the abbreviation of dead load, okay? And for the components, it should be total component, should be the whole building, okay, the whole building, and here because I'm using x z there z axis, okay, so I'm gonna go if I want, let's say if I want to know the shear of this building, the shear deformation of this building in dead loads part, I'm gonna just click on this area here, FYZ, okay, and I'm gonna scroll down, and here we have the type of display. We have a lot of function here. We have a lot of type of display. So I'm gonna take contour. I will take deform, and also I'm also check values, okay, and then for the output section location, I'll pick minimum and maximum, okay? And but if I put minimum and maximum, I'm gonna have a lot of values. Let me just take by members. Then I'm gonna click on apply. This is a lot of values. Let me go on a what maximum value. Okay, let me just do this. Okay, so this is the deformation diagram. So this is how the beam deform. Um, this is how our beam deform, the column beam and the beam, like this is how the columns and the beam deform, right? And the dead loads, okay? So if when I see the shape, the deformation shape, it's better to uncheck value and then click it and apply. Okay, let's just click on deform first of all. So this is how the diagrams looks like, sorry. Let me zoom for you. This is how the diagrams can see. Okay, you can see for the columns we have the diagram in axial forces. These forces they cause most of them in the columns. They cause most of them are caused with how can I say of the lateral forces, right? The wind loads, and also seismic loads, right? So I'm gonna show you later. So this is the diagrams. You can check the diagrams, or you can um, uh, if it's not clear, what I usually do, I usually select like so if it's not clear, I usually select one section. Like I can just select one section and then display. Let me just select one for you. I can select this part. No, it's a bit tricky, right? Select this part. Mm. Okay, let me just select one part and then you can understand what we're doing. So I'm gonna just select let me just select this beam here, and then I'm gonna activate this part. And this is what we can do. All right. So this is the shear forces. This is the shear forces. We can do this legends and then apply. So this is the shear in X and Y direction on this beam, on this particular beam that I selected. Let's add values. I can select value because it's not the whole building. So let's see. Okay. Oh, sorry. Sorry. Here, yeah, you can see the value. These are the values, right? On this beam. These are the value. You can see we have 738.7, and here we have 471. Okay, this is the value, means that if you apply force in the middle here, like the maximum force is in this middle, but the left part is gonna deform. This is the peak. This is gonna be the peak on the left, but it's gonna be the peak forces on this left part, and this is gonna be also the peak on the right side. If you apply force here of the specific load that we defined before, the dead loads on this beam, this is gonna be the deformation. We can also change. We can also change the moment. The moment is the rotational section on this beam. So I can click OK. This is gonna be the deformation on this beam. This is gonna be the deformation. I mean the rotation of the beam. The peak one is be 4.4, I mean 4,000, and also this peak, the right peak, are gonna be 1,600. This is gonna be the one. So this how you can check the moments on this beam, right? And how can you can reinforce it in the future in the next video. Then can change. You can also change. You can also change the load into live load, and then apply. You can see the moment has changed because we're applying live loads, right? Live load on this particular beam. This is how it's gonna react. The beam gonna react. We can also change. We can also change to wind load in X direction. It's gonna be a little bit 0 or something, like few, because as I said, most of the time the wind load it's applied. Let me just activate everything. As I said before, the wind load most of the time it's applied on the columns, right? As you can see, our columns absorb a lot of forces, right? You can see the columns. Let me just pick one column. The bottom, the first floor, because the first floor is so important for the stability. Let's do this. Let me just select one of these, okay, and then activate. Then activate it. Okay, all right, and then let me click values, legend, and also apply. You can see this is the forces. This is the shear. This is the moment on this column, right? In wind direction. So the wind directions cause this effect on these columns, right? So you have to know how to reinforce this column. In the next video, I'm gonna show you how you can reinforce this column in order to maintain the stability according to these values that you got. Okay. All right. You can also repeat the same for wind load in x direction, in y direction, then apply this y direction. X direction is 0, y direction is 96.6, and this should be 1.8, I mean 18.4. All right, so this is how you can check the value and also the diagrams. Okay, and let's do this. Let's activate everything. Oh, sorry. Let's activate everything. Let's activate everything again, and let's remove everything. So now you can see the deformation. So this is how the deformation is. So this is how our, okay, because it's y direction, right? Our building will be deformed. Let's change it. Let's change in x direction. So you can see, right? Since we apply load in x direction, our building will deform in x direction. And if you apply in y direction, wind load in y direction, it's gonna also change in y direction. Okay, so this is how you can know how your building reacts according to the load that you applied. Okay, and we can also see the dead loads. Dead load is the main part of the structure. Dead load, this is how dead load is more about the vertical, right? The vertical forces, right? In the vertical forces, this is how it can deform the moment it's gonna cause this deformation on the building. You can also see how the shear force is gonna be. If you apply, you're gonna see this is gonna be our deformation, shear force deformation. Okay. All right. So in the next video, I'm gonna show you how to reinforce the house according to these to these results, right? And if you don't want to miss this opportunity of learning a lot of stuff, just make sure to join the community, to share this video, and also to subscribe to this channel, guys. It's so important. And also like the video, guys. It's gotta be so important, guys. And thanks so much for support. And see you in the next one. Bye bye. See you in the next one. Bye bye.